This class we work out 3 problems. First problem is a 3-phase 400 volt 50 Hz supply feeds a load of 30 kilowatts at a power factor of 0.7 lagging. The capacitors are connected between the lines across the load to improve the power factor to 0.85. The question is determine the resultant current drawn from the supply and the value of capacitors. So the load is delta connected, capacitor also delta connected. We know that power P is equal to root 3 into VL into IL into cos theta. VL is 400, P is 30 kilowatts, cos theta is equal to 0.7, theta is equal to minus 45.57 degrees. The minus sign indicates power factor is lagging. Now we can calculate the line current. IL is equal to 30 into 10 power 3 divided by root 3 into 400 into 0.7. Line current is 61.86 amps. In delta connection, line voltage is equal to root 3 times phase voltage. Now we can calculate the per phase current. 61.86 divided by root 3. Per phase current is 35.71 amps. So cos theta is equal to 0.7, theta is equal to minus 45.57 degrees. Per phase current is 35.71 angle minus 45.57 degrees in amps. Next we add the capacitor to improve the power factor, that is 0.7 to 0.85. Now we calculate the per phase current. We know that power P is equal to root 3 into per phase voltage into per phase current into cos theta. Cos theta is equal to 0.85, theta is equal to 31.79 degrees minus sign. Now we calculate the per phase current. 30 into 10 power 3 divided by 3 into 400 into 0.85. Per phase current is 50.94 amps. The theta is equal to minus 31.79 degrees. So per phase current is 50.94 angle minus 31.79 degrees. Next we will draw the system per phase diagram. So this current is 35.71 angle minus 45.57 degrees. Here the load is, per phase load is 30 kilowatts by 3, that is equal to 10 kilowatts. Power factor is 0.7 lagging. This current is 50.94 angle minus 31.79 degrees. This is the capacitor current IC. Now we can calculate the capacitor current IC. Applying Kirchhoff's current law. Here I dash is equal to IC plus this current. Now we can calculate the IC. IC is equal to 18.35 angle minus 4.19 degrees. That is the current drawn by the capacitor. We know that IC is equal to V into omega C. IC is equal to 18.35 amps. V is equal to 400. Omega is equal to 2 pi f. Now we can calculate C. C is equal to 18.35 by 2 pi into 50 into 400. C is equal to 1.46 into 10 power minus 4 farads. Or C is equal to 146 microfarads. So the resultant current is 50.94 angle minus 31.79 degrees. The capacitor value is 146 microfarads. Second problem, a 3-wire 3-phase system with 400 volts between lines supplies a balanced delta connected load taking a power of 25 kilowatts at 0.8 power factor lagging. If the power factor of the system be raised to 0.9 lagging by means of delta connected capacitors, calculate the kVA rating of the capacitors. That is the question. So the total load supplied is 25 kilowatts. Original power factor is 0.8 lagging. Improved power factor is 0.9. So this is 25 kilowatts. This is 36.87. Theta 1 is equal to cos inverse of 0.8, 36.87 degrees. Theta 2 is equal to cos inverse of 0.9, 25.84 degrees. So this is kVR1, this is kVR2. Load kVR1 is equal to P into tan theta 1, 18.75. Load kVR2 is equal to P into tan theta 2, it is equal to 12.11. Leading kVR supplied by the capacitor, that is equal to kVR1 minus kVR2. 18.75 minus 12.11, that is equal to 6.64. Since capacitors are loss free, so the kVA rating will be same as 6.64 kVAr. Okay. The third problem is determine the capacitance per phase when the capacitors, one they are star connected, another is delta connected. So this is star connected, this is a delta connected. So the capacitor is value is 6.64 kVAr. That is the total value. kVAr per phase is 6.64 by 3, that is equal to 2.21 kVAr. In star connection, line voltage is equal to root 3 times phase voltage. Line voltage is equal to 400, phase voltage is 231. Now we calculate the current drawn by each capacitor. 2.21 into 10 power 3, that is 2.21 kVA. 2.21 into 10 power 3 divided by 231, that is equal to 9.57 amps. So that is the IC value, current drawn by the capacitor. IC is equal to V into omega C. Now we can calculate C. C is equal to 9.57 divided by 231 into 2 pi into 50. So C value is 132 microfarads. The second case, when the capacitors are delta connected, line voltage is equal to phase voltage, that is equal to 400. Now current drawn by the capacitor is equal to 2.21 into 10 power 3 divided by 400. Current drawn by the capacitor is 5.53 amps. Again we are using the same formula. IC is equal to V into omega C. I can calculate C. C is equal to 5.53 divided by 400 into 2 pi into 50. That is equal to 44 microfarads. When the capacitors are star connected, the capacitor value is 132 microfarads. When the capacitors are connected in delta, 132 by 3, that is equal to 44 microfarads. This way I have to work out this problem. With this I conclude my lecture. Thanks for listening.